Alright, in this video we're going to talk about Unit 3, Objective 4, Partial Fraction Decomposition. This is going to be a way that we can handle certain types of quotients that we're trying to integrate. But before we start looking at an integral, let's go back in time and let's look at this problem here. 5 over 2x minus 1 over minus 2 over x minus 3. And I want to take these two things and I want to combine them into a single term, one fraction. So we need our common denominators and all of that fun stuff. So our common denominator is going to be 2x minus 1 times x minus 3. So 2x minus 1 times x minus 3. We started out on the left-hand side. We had a 5. We had a 2x minus 1 in our denominator, so we needed to multiply both the numerator and the denominator by x minus 3. And on the right-hand side, we want to do something similar. We need to multiply by 2x minus 1 over 2x minus 1. If you were to distribute your 5 and your 2 into each of these things, and don't forget that we have that negative that we would need to distribute, we would end up at x minus 13 over 2x minus 1, x minus 3, and then if we wanted to, if we felt adventurous, we could distribute the denominator out and get 2x squared minus 7x plus 3. So that's a little stroll down memory lane, looking back at common denominators, combining your fractions, adding and subtracting, all of that fun stuff. Now, why we did that is we are going to use a process called partial fraction decomposition to basically work backward with everything we just did. And the reason we're going to want to do that is you will be faced with antiderivatives of things like x minus 13 over 2x squared minus 7x plus 3. And if we look at what we have there, there's not a u that's going to work. Our u would potentially be our denominator. The du is not going to cancel out the numerator. It's not a candidate for integration by parts because it's not a product. We can't increase and divide, so our only option is going to be partial fraction decomposition. So what we want to do is we want to take everything we've done on the left-hand side of the screen and work backward. So if we start down at the bottom where it says x minus 13 over 2x squared minus 7x plus 3, and we start working our way up to the top, the first thing that you notice we do is we factor. So we're going to want to factor the denominator of what we have. So we get that 2x minus 1 and the x minus 3. And then what we're going to want to do is think just about that function. So we can say, and I'll switch colors here, we can say that x minus 13 over 2x minus 1, x minus 3 is going to be the same thing as some value a that we don't know times x minus 3 over 2x minus 1, x minus 3 plus some value that we don't know, b, times 2x minus 1 over 2x minus 1, x minus 3. Now, if we look at the left-hand side, we know, because we're working with the same numbers, we know that those a and b are going to turn out to be 5 and negative 2. But when we're working this problem just from the beginning over here, we don't know that. So we're going to call them a and b. We don't know what they are, but we know there's some number that's going to work out the same way. So if we think about what we have, we can look at this and say my numerator here has to be equal to the numerators over there, because we have that equal sign in between them. So we want to think about a times x minus 3 plus b times 2x minus 1 equals x minus 13. And our whole goal is we need to figure out what that a and b are going to be so we can rewrite this problem and end up with something that we can anti-differentiate. So we need to try to eliminate a or b to solve for the other one. So what we're going to do is we're going to let x equal 3. If x equals 3, this first term is going to give us a 3 minus 3, which is 0 times a. So 0 times a is just going to go away. If we plug a 3 into that second term, 2 times 3 is 6 minus 1. We have 5b equals, and then we have 3 minus 13 is going to be negative 10. So we know our value of b is going to be negative 2. Now we want to do something similar to get rid of our b, so we're going to let x equal 1/2. So if x is 1/2, if we look at that second term, 2 times 1/2 is 1, 1 minus 1 is 0, so we're going to have 0 times b if x is 1/2. Now if x is 1/2, we're going to have 1/2 minus 3, and that's going to give us negative 5/2 a is going to be equal to, on the right hand side of the equal sign, we're going to have 1/2 minus 13, and that's going to give us negative 25/2. So if x is 1/2, we know that negative 5/2 a is equal to negative 25/2. So we know that a is going to be equal to 5. So if we know a and we know b, we can plug those back into, so we can take these, change colors again. We can take these and plug them back in here. So we're going to end up with 5 times x minus 3 over 2x minus 1 times x minus 3. Then we have negative 2, so I'm just going to say minus 2 times 2x minus 1 over 2x minus 1 x minus 3. We can cancel out some terms, so the x minus 3 and the x minus 3 can cancel, the 2x minus 1 and the 2x minus 1 can cancel. So we're going to be left with 5 over 2x minus 1 minus 2 over x minus 3. The whole point of this was to rewrite our original problem that we had up here in such a way that we could anti-differentiate. Well, we did our whole complex or our partial fraction decomposition to rewrite the inside like this, so we can rewrite the entire problem as the antiderivative of 5 over 2x minus 1 minus 2 over x minus 3 with respect to x. Now I'm going to leave that anti-differentiation up to you, but all we would need to do is use a u substitution on each piece, and we're going to end up with some natural logs because we're going to have u in the denominator. But the whole purpose of this is we need to work backwards from a fraction to make it into two fractions. Unlike what we did in previous math classes where we had two fractions, combine them into one, we want to take one and decompose it into two of them so we can take an antiderivative. So that'll do it for this video. We'll see you in the next one.